Hello everyone. So we are continuing with the Boolean algebra chapter. In the previous video we discussed about universal logic gates. Today we shall see some examples based on those gates and also the fundamental gates. So here we have to draw this circuit based on this Boolean expression. As you can see that this is a Boolean expression, so this is mean terms. As you can see, the mean terms, these three mean terms. So these are the literals x and y, and the dot represents the and, so which is multiplication, and this plus symbol represents or, which is addition. So as you can see here that uh, x and y, or x and y, or x complement y, or x and z. So now based on this circuit, we have to use we can use the fundamental or the basic gates, that is and or. So we don't need to use the derived gates because it's not written here in the question that you have to use only the NAND gates or NAND gates or NOR gates as in the previous video. So we can use the fundamental gates. So here if you see that since this mean term represents the multiplication, so we know that AND gate is used for AND gate, it represents multiplication, so that's why we have this AND gate. And you know that AND gate, it accepts two or more inputs. So here that's why we have two literals here that represents x and y, and no matter how many inputs is there in the logic gates, the output will be only one, which is x dot y. Then similarly here also we have another AND gate which represents x complement y, so the output we get x complement y dot y. For a third, again we have another AND gate. So we have three AND gates where we get one output each, that is x into y, okay, x complement into y, x into z. Now to get this plus symbol, we know that in the fundamental gate, OR gate is used to do the summation. So for that we have this OR gate. So all of the three inputs are directed to this OR gate. So the result of that is we get these mean terms added. So this is how you draw the circuit based on this expression. So excuse me. So during exam time, what you get is you'll be getting only this expression. You'll be getting this expression, and sometimes what you will be getting this diagram, circuit diagram, without this expression names, and based on those diagram you have to write down the Boolean expression. All right. So it can be quite the reverse also. Now again you have to draw the circuit based on this mean-term expressions. So you can see that here you at first you are using the OR gate because it is a plus b, and then multiplying it with b plus c complement, multiplying with a plus c complement. So since it is within the parenthesis, so anything that is within the parenthesis is executed first, so that's why we have the OR gate written first. All right. So so you have two inputs a b, and you get a plus b, okay, b c complement, you get b plus c complement, and then you get a complement plus c. Since you have to multiply all of these three literals, okay, so that's why you use a AND gate. Okay, so the outcome of that will be this. So once you understand all the fundamental gates and the output, how it is derived, and the derived gates, how you get the output, okay, drawing this circuit diagram will be very much easy for you. All right. Or reducing this circuit diagram into an expression will be much easier for you also, right? So practice as much as possible from all the solve exercises. Now here we have a Boolean expression for this logic diagram, which is shown here like this. So so in the diagram this is not written, okay, a dot b c c complement y equal to a dot b plus c complement. But here what we have to do is that we have to find its output when a equals to 1 and b equals to 1. All right, so when a equals to 1, b equals to 1, so the solution is, okay, judging on the logic diagram. So you have to see the logic diagram, okay, and based on this logic diagram, as I said, that this is not mentioned, this is not mentioned, and this is not mentioned, we have to based on that we have to get this. So just by looking at the logic diagram, you have to see that here you are using an AND gate, you're using NOT gate, you're using OR gate. So when you're using the AND gate, it will be a and b, that is a dot b. And when you're using the NOT gate, you know that NOT gate can take only one input and one output will be displayed, which is the complement of that. So you get c complement. And then you have the OR gate. So OR gate will do what it will do, it will sum up these two minterms. So that's why you get y equals to a dot b plus c complement. So according to the logic diagram, you get this expression. So now when a equals to 1, b equals to 1, and c equals to 1, you insert the value. So y equals to 1 dot 1 plus 1 complement. 1 complement is 1 only. So here you get y equals to 1. So the output of that will be you get 1. Alright. So now you have the truth table to verify, use the truth table to verify the following expression. So here you have a plus b, the whole complement equals to a complement dot b complement. So you have here the De Morgan's theorem expression. So based on that, you have to draw the truth table. So in the previous examples, using the expression, you had to draw the logic circuits. Now here you have, based on this expression, you have to draw the logic table. Alright, so the truth table. So here you can see that first, based on this truth table, what you have to do is that first a plus b has to be executed first, and then after that this a dot b has to be executed. So LHS has to prove that LHS should be equal to RHS. So based on that, first you have to insert the value of a and b. After that, you have to find a complement, b complement. So you can see that here, when there are two variables, you can form only four rows of input values. So that is 2 to the power 2 equals to 4. So 4 possible combinations. So you have 0 0 1 1 and 0 1 0 1, right? Now a complement will be 0 becomes 1, 0 becomes 1, 1 becomes 0, and 1 becomes 0. Similarly, for b complement, 0 becomes 1, 1 becomes 0, 0 becomes 1, and 1 becomes 0. Alright, so a plus b, as you can see here, when you add this up, you get this following output. Similarly, a plus b, the whole complement, what you do, first you add a plus b, you get this value. And then when you complement this, you get 0 to 1, okay, 1 to 0, like that. So finally, when you multiply this a complement b complement, that is this and this, not this one, okay, this, so LHS is this one. So now when you multiply this, you get 1.1 equals to 1, 1.0 equals to 0. So you can see that LHS is equal to RHS. Okay, so using this kind of method, okay, you can find the values, or you can find out that, okay, LHS is equal to R. You have to prove that. So different methods of simplifying the Boolean expressions, using the truth table, using the logic gates. All right, so practice on all the solve exercises. Okay, so in the next video, we should start on the revisions from starting from the review of C++, right?